Now, this problem is asking to approximate this integral using the midpoint, trapezoidal, and Simpson rule for n equals 6. So we don't have a technique to integration directly. So we're gonna estimate this integral using one of these rules. So I'm gonna go ahead and set up the bound for the trapezoidal and Simpson rule. So for the bound, the rate is between 1 and 11, and I need to cut this into n equals 6 intervals. So we're going to have to find delta x, and delta x is going to be b minus a over n. So this is my b, and this is my a. So it's going to be 11 minus 1 over 6, and that will be 10 over 6. Simplify it, we have divide both top and bottom by 2, we have 5 over 3. So my increment for each sub-interval will be 5 over 3. So it means I'm gonna will 1, 2, 3, 3 sub 4, 5, 6. Okay, so it's gonna be 1, 2, 3, 4, 5, 6. 6 sub-interval, and each increment, the delta x, will be 5 over 3. So I'm gonna take 1 plus 5 over 3. So let's go ahead and add that 1 plus 5 over 3, which is 8 over 3. And then I'm going to keep adding 5 over 3 to my fraction, 5 over 3. And that will be 13 over 3. And then 18 over 3. And then 21 over 3. 24 over 3. And 27 over 3. I'm adding wrong, okay? I think I added wrong here. So I have 18 over 3 is correct. And then after 18 over 3, it's going to be not 21 because I need to plus 5. So 18 plus 5 is 23. So 23 over 3, and then 28 over 3, and then 33 over 3, which is 11. Okay, so that is all my value for the x. Now gonna be the trapezoid rule and Simpson rule sharing the x value. So I'm good with that two rule. And now I'm gonna need to find the area using the trapezoid for the 6 subinterval. So I'm gonna call that T6. And the rule is delta x over 2 for trapezoid. And f of the first one plus everything in the middle will be multiplied by 2 for the output. So I'm gonna do 2 times f of 8 over 3 plus 2 times f of 13 over 3, and then keep going until I get the last point. And the last one will be no coefficient. We don't multiply by 2 for the last one, okay? And how do we find f of 1, f of 8.3, a over 3? We're going to put that back into our function. So our function here, this one is our f. So my f of x is ln x over 5 plus x, okay? So in your calculator, you're going to put f of 1 will be ln1 over 5 plus x, okay? So I'm gonna pull out my calculator again, and I will enter those number in. So let's assume you just have a scientific calculator, then you will have to enter everything manually. So I'm gonna do 5 plus 1. Okay, so that is my first one, which is 0. So f of 1 is 0, f of 2. So I will do delta x is 5 over 6. 5 over 3. So I wrote that 1/2 times 5 over 3. And then the first term is 0. Now the second term, 2 times ln of 8 over 3, 5 plus 8 over 3. And I got 0.25 586. Okay, so I'm gonna round, but remember when you round, you're gonna have a lot of rounding error. So on the exam, I mean, yeah, I don't want to say that here, but we're gonna keep the decimal point as much as we can, so we don't have any rounding error. Since we already estimate, we don't want to rounding too early. So I'm gonna keep going. Same thing, just replace the 8/3 by 13/3. And then continue to find the next one, 18/3. All right, so I already entered everything. So if you could get everything go together, like what I'm typing here, all at the same time, then I will avoid a lot of rounding error above here. If you can see, I actually typing all of the function into here, and then I have the answer is 1.679, and then I gotta multiply 5/6. If you have a scientific calculator and you won't be able to type everything in at the same time, then yes, at that point you might need to calculate everything like individually and then add them all up. Okay, so on my when I'm writing down on my paper, I just do 2 decimal point, so I don't need to like write too much on that. 0.14. Okay, and you can see I have a lot of rounding error because I draw all the decimal point in the back. However, this is gonna be the one that I typing together. So I have 1.6. So I should not put the equal sign. I should say this is an approximate sign, approximate, and that's gonna be 5/6 times 1.679, and then I multiply that by 5/6, and I will get 1.399. Okay, so this is for the trapezoidal rule. And then for the Simpson rule, we're gonna use the same value of x. The only difference is their coefficient. Okay, so for the Simpson rule with 6 subinterval, we will have delta x over 3 instead of over 2. And then we also have f of 1, but instead of 2 times f of 8/3, we have 4 times now. And then 2 times f of 13/3 plus 4 times f of 18/3, and so on. We just keep alternating the 4 and the 2. So the next one will be 2, and then 4, and then the last one still no coefficient. Okay, so the first and the last one have no coefficient. And then now we just continue to do our calculator again. So seeing everything is just there, I just need to go back using the cursor to select that again, and then change all the coefficient that I need is to be 4. So for the a/3, I need that to be 4. So this one is 4, and then 2, 18/3, I need it to be 4. And then 2, and then 28/3, I also need that to be 4. And then the last one. Okay, so this is my what I have for my calculation. So 2.5723. So I will have approximate 1/3 times 5/3, and then times I have 2.5723. 2.5723. Okay, and then I multiply that by 5/9, because 1/3 times 5/3 is 5/9, and then we got approximate 1.42906. Okay, so that's how the trapezoid rule and Simpson rule. Now, the only difference is the midpoint rule. So midpoint rule, we're going to have to find a new point because it's not going to be the same value of x that we use for the trapezoid and the Simpson rule anymore. We're going to have to find the midpoint of these x value. So it means I will need to find the middle value of these. This, and this, okay? And how do we find that? We're going to take the first number, add the second number, and then divide by 2. So 1 plus, we're going to have 1 plus 8 over 3, divide by 2, we have 11 over 6. Okay, so our first value is 11 over 6, and each increment will be still the same. We also plus 5 over 3 on that. So adding 5 over 3, we have 3.5. 3.5, or you can keep it a same denominator. So you're going to have 16 over 3. I mean, no, not 16 over 3. I will make that become the same denominator so that it's going to be easy for me to adding the next number. So this is 7 over 2, which is, so let me do by hand first, 5 over 3. So multiply by 2, I have 11 over 6 plus 10 over 6. So it's going to be 21 over 6 for the next one. And then each time I just adding 10 over 6. Okay, so 31 over 6. And then why I adding 5 over, 10 over 6? Because the 5 over 3 is I make it become denominator of 6. I have 10 over 6. Okay, so each time I'm going to adding 10 over 6 to the increment. So it's going to be 41 over 6 and then 51 over 6. 61 over 6. Okay, so when I find out all those points, then I can actually evaluate my area now using the midpoint. The midpoint gonna be delta x times f of all the number that we just found without any multiply to any coefficient. So the coefficient is all 1. So we just multiply all that. Okay, so now we're gonna put everything to your calculator, to the calculator and calculate what do we have for the final answer. So our delta x still 5 over 3. Okay, still 5 over 3, and then we're gonna figure out what is the whole bunch of thing right here. Yes, we still put this number back to our function. Where's our function? This one. Okay, so we're gonna put in ln of 11 over 6. ln of 11 over 6 divide 5 plus 11 over 6. Okay, so that is the first value. Make sure you put the parenthesis when you divide the two terms in the denominator, otherwise your answer will be different. And then we just keep going to input the rest. All right, so now everything I already type in my calculator. So the typing part and the calculator calculation is, you will need to be very careful because it's really easy to make mistake. Okay, so I'm gonna have 0.871456, and then we're gonna multiply that by 5/3, and I will get the approximate of 1.4524. Okay, so that is my midpoint rule. So, and you can see midpoint, trapezoid, and the Simpson, the value is really close to each other. However, they're not going to be the same. They are close to each other because they are 3 different ways, 3 different techniques to estimate. But this is going to be what we're going to do. Okay.